Hey everybody, welcome back to the final portion of Unit 8 Day 1 notes. We're going to start this section with the greatest common factor. A GCF, also known as the greatest common factor, is known as the largest factor that the terms share. So now we're going to start off with example number 1 to determine the greatest common factor here. The first number that we need to break down is number 20. In order to do this very quickly, you can open up your calculator and go to the table feature and divide 20 by x. Press enter, start at 0, step by 1, auto, and OK. We'll see that our first factor pair up here is 1 and 20. That means that these two numbers multiply together to be 20. The next factor pair is 2 and 10. For GCF, we only want the largest whole number. So when we scroll down to 3, we see that it's 6.6667. We won't use that since both of the terms are not whole numbers. We scroll down and we get 4 and 5. And if we scroll down one more time, we get 5 and 4, which is a repeat of the line right above, so we will not write it. We're going to do the same process with number 48. We're going to take 48, divide it by x, start at 0, step by 1, and write down all my factor pairs. So for 48, we have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 and 9.6 won't work since it's a decimal, and then 6 and 8. 7 goes with the decimal, so it will not be used. And then we have 8 and 6, which is a repeat of the line above it. So we will leave it right there. Now we need to look to find the greatest common factor. So we're going to start with the number 20 to see if 20 is shared in both the 20 column and the 48 column. It is not. We're going to look again to 10. It is not shared in either column. We're going to look at 5, not shared in either column. The only number that we are left with is 4. So 4 will be the GCF of 20 and 48. Moving on to number 2, we have x squared and x cubed. This is going to look a little bit different. We know that x squared is made up of 2 x's. And x cubed is made up of 3 x's. Here we're going to take the highest amount of x's from each grouping to find my greatest common factor. So we can take one x from x squared and x cubed, and another from x squared and x cubed. That is the highest amount that we can take from both groups, so my greatest common factor will be x squared. Moving on to number 3, we're going to find the GCF of this expression. To find a GCF of an expression, it is the same exact way that we use to find the GCF of 2 different numbers. We're still going to split it up into 2 columns and find my terms. You should know that the only 2 things that multiply to be 3 are 1 and 3, and then we have an x left over. For 6, the terms that multiply to be 6 are 1 and 6, 2 and 3. So we know here that the highest number, the largest number that they both share is 3. Also, when you take a GCF of an expression, usually you don't write just the GCF. You write it factored out. So you're going to divide 3 from every single term since it's the GCF. So 3 will be out front, and it leaves me with x plus 2. Moving on to number 4, we have x squared and 2x. X squared breaks down to 2x's. 2x breaks down to 1 times 2 and 1x. We have an x in x squared and an x in 2x, and nothing else is shared. So my GCF is x. And if I do the process that I just showed before and divide out x from both of my terms, bring it out front, it'll leave me with x plus 2. Number 5, we have 4x squared plus 8x. 4 breaks down to 1 times 4, 2 times 2. And for x squared, we have 2x's. For 8x, this breaks down to 1 times 8 and 2 times 4, with only 1x. We see that they both share 1x, and my GCF will be 4. My entire GCF is now 4x. If I factor that out from my problem, I'm left with x plus 2. And last but not least, number 6. Same idea here, except we just have 3 terms instead of 2. So I'm going to break down 3x squared to 1 times 3 and 2x's. 2x to 1 times 2 and 1x. And 9 to 1 times 9 and 3 times 3 with no x's. Again, when you have a GCF, it is the largest number that all of the terms share. So in this case, it looks that 3 might be the GCF. However, my middle term, my 2x, does not have a factor of 3. So the largest number that they all share is the number 1. All 3 of my terms here do not have a variable, do not have an x, so x cannot be part of my GCF as well. So, for number 6, there is no GCF per se. Well, you might be thinking, well, 1 is my GCF. 1 is not technically considered a GCF. We will never write 1 as my GCF in a problem. So if 1 is the highest number that they share, no GCF will be your answer. There's the zoomed out version for you. Pause it here if you need to finish writing. Now we're going to move on to find the greatest common factor of all of these expressions. So first, we're going to find it of 3x to the 4th minus 12x squared. We're going to break down 3x to the 4th. We know that 3 breaks down to 1 times 3, and x to the 4th leaves us with 4 x's. Next, we're going to break down 12x squared. In our calculator, we can do 12 divided by x to make sure that we do not skip any factors. So here I have 1 and 12, 2 and 6, 3 and 4, and x squared leaves me with 2 x's. Now we're going to find the largest number that they both share. We'll always start with the smaller column to look for our GCF. The largest number there is 3, which is also shared by 12x squared. We can take an x from 3, an x from 12, another x from 3, and another x from 12. So my GCF will be 3x squared here. when I divide that out of my problem and rewrite it, it's going to leave me with x squared minus 4. All right, number 2, we have 6y squared minus 3xy. We're going to break down negative 6y squared. We have 1 and 6, 2 and 3, and 2 y's. Also here we have a negative out front. For my second term, it's negative 3xy. So you have 1 and 3, 1x, 1y, and a negative. Now we're going to find my greatest common factor. The largest number that they both share is a 3. They do not share any x's, but they do share one y, and they also share a negative. My GCF here will be negative 3y. And when I rewrite that, I will get negative 3y, and it's going to leave me with 2y plus x. If you're wondering what we're doing here, when we factor it out, it's basically just simplifying and pulling the GCF out front. If you were to multiply this expression together and simplify it, I'll get negative 6y squared minus 3xy, which is my original problem. I'm just writing it in a different form to show my GCF. Moving on to number 3. We're going to break down x cubed. That breaks down to 3 x's. Break down 4x squared, which is 1 times 4, 2 times 2, and 2 x's. And negative 6x, which is 1 times 6, 2 times 3, an x, and a negative. Now we're going to find my greatest common factor. The only thing that all of these share is one x value. So x will be my GCF. When I rewrite it by dividing out the x from my original problem, it'll leave me with x squared plus 4x minus 6. Now we're going to move on to number 4. We're going to break down 36 x squared y. I'm going to go back to my calculator and in my table do 36 divided by x so that I can get all of my factor pairs. 1 and 36 is my first factor pair. 2 and 18. 3 and 12, 4 and 9, 6 and 6, with 2 x's and 1 y. We'll do the same thing with 16xy. I'm going to put that back into the table on my calculator. 16 divided by x, start at 1. And that will give me all of my factor pairs. So I have 1 and 16, 2 and 8, 4 and 4, with 1 x and 1 y. Try this problem, pause here, and come back for the answer. Here's the answer for number 4. Please take this time to finish up the rest of this notes page, practice GCF, and the answer key will follow this video. Thanks!